This is the presentation for behavioral economics. The title of the paper is Experimental Analysis of Risk and Uncertainty in Provisioning Private and Public Goods. It is written by Lata Gangadharan and Veronica Nims. It's published on Economic Inquiry in 2009. Let's get started. Motivation. In the standard public goods game, there is no uncertainty with it. However, in some situations, there are uncertainties and risk. The presence of uncertainty might be important in provisioning a public good and also the policy making. And the example is classic public good problem, which is climate change. This will be explained on next slide. So introduction. Before we dive into the paper, we first have to understand four terminologies. In economics, risk and uncertainty have different definition. When we know the probability of the future events, it is risk. If we don't know, it is uncertainty. And in this paper, it used the terminology strategic uncertainty and environmental uncertainty, which was first introduced by Masick, Ellison, and Samuelson in 1998. Strategic uncertainty is uncertainty due to not knowing how other people will behave. So when subject invest into public goods, it has strategic uncertainty because the people don't know how other people will invest into public goods. Environmental uncertainty is, by definition, environmental variables that determine which group action is best. In this case, it is the probability of return. At this moment, it might be not clear, but it will be explained later. So in real life example, the climate change, that's the case of uncertainty because there's no precise predictions or estimates about the climate change in science or economics. However, about ozone layer depletion, that is a case of risk because there is actually more detailed research about it and how the ozone layer depletion can affect human body. So what this paper wants to answer is how individual perceives risk and uncertainty when making decisions about public and private good. So the model of the experiment, there are 10 sessions. Each session involves 5 subjects, and the subject can only participate in one session, and therefore there are 50 subjects in total. There will be 7 treatments, which will be explained later, and each treatments have 15 decision-making periods. And prior to the experiment, they asked lottery game to identify the subject's risk preference, and this is similar to the one introduced in Brown and Stewart and Holt and Lowry. So individual I's payoff in this model is written here. This part is the private account. This part is the public account. So at the start of each period, each subject receives same number of tokens, denoted as omega, and they can either invest into private or public good. If they invest xi amount into private account, they will receive alpha xi with probability x, px, and if they invest into public account, they will receive beta g over n with probability pg. So G is the summation of all subjects' public good invested, and N is the number of players. And PX, PG are probabilities of receiving the return, and at the end of each period, subjects learn about the result. So the contribution level, return from private good and public good. So this is the treatment. So it starts with the 100 tokens, and like I said, there are 5 people per session. So in the baseline, so treatment 1 is basically the standard public goods game, and that is why it has probability 1. And right now you can ignore this part and just mainly focus on the probability. So in treatment 2 and 3, it's the risk on private good and public good. So for treatment 2, now the private good has a risk of 0.5, and this is known to the player. For uncertainty, that is treatment 4, 5, and also 6 and 7. In treatment 4, it is Px or Pg is drawn from uniform distribution. And for each period, the computer generates random number r between 0 and 1. And if the probability is greater or equal to r, the subject will receive the return from the count. So interesting fact is that this can be requested. So subjects must pay 20 tokens to reveal the probability. So this is what unless requested means. And this means that people can convert uncertainty into risk. For treatment 6 and 7, there is incentives to invest into that account. So for instance, for PXI, if you put 1 unit into private account, this will increase XI, which will increase the probability. So the subject can actually increase the probability by investing more to the account. So the probability is unknown, but they know that they can increase the probability. So this figure shows the result from the 10 session, and on average around 20% contribution level, except for treatment 2 and 4. So treatment 2 was the risk on the private goods, and treatment 4 was the uncertainty on the private goods. And comparing treatment 7 with 5, so treatment 5 was when there was uncertainty on the public good, and treatment 7 was that there is incentive to increase the probability. And it shows that the contribution level has increased when there was incentives. This figure shows the average contribution levels relative to the baseline treatment. It basically shows how the treatment have impacts on the standard public good game. So the baseline, the treatment 1 is at 0. The deviation from the baseline can be seen as the impact of the treatment. So only treatment 2 and 4 has higher contribution level than the standard public good scheme. And other treatments shows less contribution level. And this figure shows the average contribution levels over the 15 periods. All treatments start with relatively high contribution level, and it shows decreasing trend. And this can be interpreted as subjects make decision using the information in the previous period. And this figure shows the contributions to the group account with environmental risk and uncertainty. So the TR4 risk, which is this line, there is a risk on the private good. And as the probability of the return from the private good, the PX rise, the contribution level to the group account decrease. When there was a risk on the public good, and as PG rises, the contribution increase. When there is uncertainty on private good, it shows that contribution is about 50%, regardless of the actual probability of the private good. However, when there is uncertainty on public goods, it drops to 5%, regardless of the actual probability of the public goods. So this shows that subjects usually prefer private good over public good. And in treatments 4 and 5, probabilities are unknown unless requested. And the ratio was that for the private good, 43% wanted to reveal the probability, and for public good, it was only 13%. Interesting fact is that there were few people who paid the fee but didn't use the information in their decision making. So for example, they have paid the 20 tokens and revealed the probability, and they found out that the probability of the return from private good is low, and probability of return from public good is high. So like, let's say this was 10% or this was 90%, but after seeing the probability, they still invested all of their tokens or most of their tokens into private good. So this can be interpreted as aversion from strategic uncertainty. So although there is unfavorable probability of return, it is still better than contributing to public good. Because public good has strategic uncertainty, they prefer private good over public good. So the conclusion. So from this paper, we can conclude that uncertainty and risk play important role in decision making. So the subjects use feedback from other players as information about the strategic uncertainty. So this means others' decisions made in the past periods affect decision making. So they use the information from the past periods to identify the strategic uncertainty and take this into account and make decision. And the result is consistent with the Dickinson in 1998. So the person's contribution in previous round affects individual contributions, and the result confirms Festinger's conjecture in 1954. So as probability in the previous period increases, the contribution increases in this period. And the result also shows that the subjects move away from the environmental uncertainty or risk. So when there is uncertainty or risk on the private or public goods, it will decrease the investment amount. So looking back to the figure 1, so like for example in treatment 2 there was a risk on the private account, and this make the private account contribution level drop and increase the group account contribution. So, and when subjects face both strategic and environmental uncertainty, this leads to significant drop in the contribution. So like treatment 5, for example, there is strategic and environmental uncertainty, and that's why the contribution falls below 20%. And also comparing the treatment 7 and 5, we can see that if there is opportunity to reduce the uncertainty, so in this case there's incentives to increase the probability of return from the public good, it can actually increase the contribution level. So this was the end of the presentation. Thank you.